Hello everybody, welcome to the second video. In the last video, we calculated the rainfall erosivity and rainfall erodibility of USLE equation using the global data sets. So in this video, we will be calculating other three components of USLE, which is the topographic factor, cropping management factor, and practice support factor. So let's start with the topographic factor. Topographic factors LS consist of slope length L and slope steepness S. Increase in slope length causes increase in erosion due to a progressive accumulation of runoff in the direction of downslope. Increase in slope steepness factor S increase the soil erosion as a result of increasing velocity. The slope length is calculated by the following equation, where FA stands for the flow accumulation and M ranges from 0.2 to 0.6. This formula was developed by Moore and Wilson in 1992, whereas slope steepness can be calculated by the another formula, where beta stands for the slope angle in percentage and N ranges from 1 to 1.3. The value of M and N can be obtained from the literature or it can be based on the dominance of the slope angle. So finally, the topographic factor LS is the product of slope length and slope steepness divided by 100. For this, we require the digital elevation model. The SRTM 30-meter DEM can be obtained from the following link. So when we retrieve the DEM, we first calculate the flow accumulation using the drainage function in ArcPro. Similarly, we can calculate the slope using the digital elevation model. So let's go to this link first. When we go to the link, it will show this home page. So the downloading is very straightforward. So we go to our area of interest. So we click on the area of interest and it will pop up with this message. So we can download the DEM and save it in our computer. But before downloading the DEM, we first need to put the username and password of the earthdata.nasa.gov. So if you have the username, you can add it. Otherwise, you have to register and make an account in the following link. So once we download, we can go back to our ArcPro. So I have already downloaded the DEM, so it can be accessed through the catalog. So let's go to the DEM. Yeah, let's add the DEM to our map. Okay, so once the DEM is added, we will be doing the same methodology, which is the extract by marks. Okay, then go to the input. The SRTM is the input raster. The feature marks would be Than Trong, and then let's name as DCDEM. If we run, yes, then we will get the DEM of the Than Trong area. Now, to calculate the slope length, first we have to fill the sink. You can type fill sink and use the fill. Choose the TC DEM and you run it. So now you have the fill DEM. Then you can go to the flow direction function, click on the flow direction. You can add the input surface raster as fill TC DEM, others let it be default, and you can run it. So here you go, the flow direction. This is the flow direction. Now finally we need flow accumulation. So input the flow direction raster, which is the flow fill 1, then let it be same, so we can run it. Yeah, So this is the raster that we need to calculate the slope length. After we find out the flow accumulations, we can go to the raster calculator. Raster calculator, yep. Then what we do is we input the formula that I have shown in the slide, which is this L is equal to FA into cell size divided by 22.13 to the power n. So so in the ArcMap, I think in the ArcMap we can use this formula, Control C, and yeah, Control V. So in case of FA, we will be using the flow accumulation. We are using 30 because it's the cell size of the DEM, and yeah, so this is the L part, which is the slope length. Okay, so let's and for the M we are using 0.5, which can be obtained through the literature. So when we run it, okay, it says raster calculator failed. Maybe we require some parenthesis. Flow accumulation into 30.3. Oh, we should use power. Okay, power. Okay, L, let it run, and there you go. This is the slope length of our study area. Now let's calculate the slope steepness. For that, let's go to our slide and copy this one. Control C, Control V. Oh, so before that we need to first find out the calculate the slope from the DEM. So let's go back, click on slope. Okay, so the input raster is our fill DEM. Output raster is the slope fill T1, and we need this in percentage. So let's run it. And there we go, we have this slope. Once we get the slope, we again go back to the raster calculator. Yep, this one. So go back to our slide with this. So this should be power. And sine, is it all capital? Let me check. Okay, sine, the slope percentage should be slope fill T1. Yeah, okay, so this should be our S. Maybe there's some mistake. Sine into this. Run it. There you go. So this is what we get for the slope steepness. Now let's calculate the topographic factor, which is the product of slope steepness and slope length. Then finally we L multiplied by S. Okay, let's put some parentheses maybe. Divide by 100. So this should be LS. If we run, so there you go. So this is the slope length that we got, which ranges from 0 to 227.37. So in this way we can find out the third component of the USLE equation. The next component in the USLE is the crop vegetation and management factor, denoted by C. It is used to determine the relative effectiveness of soil and crop management system in preventing the soil loss. This value can be assigned for different land cover classes from the lookup table in the literatures. For this, the land cover data, we will be using the Sentinel-2 land use land cover, which is the 10-meter resolution, and it can be accessed through the following link. The last component is the support practice factor, which is represented by P. It reflects the effects of practices that will reduce the amount and the rate of water runoff and thus reduce the amount of soil erosion. These values can be obtained from literatures based on the farmer practices. For easy interpretation, for this tutorial we will be using the value of 1 irrespective of the land cover classes. So let's first go to this link. When we click on the link, it will direct us to the this home page. So this is the Sentinel-2 land use land cover downloader. Here, so this the download is straightforward in this case also. So we first go to our study area, in our case, which is the Vietnam. So if we click on this, if we click on the tile, it will show us the options to download the scenes by year. So we can download the scenes by different years. So we will in this case we downloaded the 2020 data. So if we click on it, we can easily save this data to our computer. So let's go back to our Arc Pro now. So I have already downloaded the land use land cover data, which is this one. So I will input it. So it will take some time to load the data. So the first step would be extract by mask with our study area. So okay, let's go to our tools. Here we can, okay, here we have extract by mask. The input raster is this one. The feature marks data is Than Chuang, and okay, so this is our LULC. So LULC DC run. Okay, so this is our land use land cover map. So let me first clean this data. So this is, so if we go to the attribute table, so the value is the different land use classes, and the count is the number of pixels inside those land use classes. So what we can do here is we will follow the similar process that we have done for the soil erodibility, if you remember. Then what we do is first we convert this raster to polygon. The idea is that we need to assign the C value, which is the crop management practice factor value for each pixels. So first we convert this raster to polygon. and input raster would be LULC TC, and the value is the field is the value, so we can run it. So now each raster is converted into the polygons. Now go to the attribute table. Here we can so our the grid code represents the different land use or the land cover classes. So here we will add a field. Let's add as C, and put this one as double. Okay, so save it, and okay. So what we can do is we can select all, copy it, and put it in the Excel sheet. Paste. Yeah, okay. So what we will do is now for each grid code or each land use land cover class, we will be putting the values. So there's a easy way. So easy way, what we can do is we can first filter it, and the value of C is obtained from different literatures. So these literatures, these references can be seen in this slide. So what we can do is okay, let me, so yeah, so this ESRI 2020 land use land cover map has 10 classes. So the number 1 representing water and so on, and these C values are obtained from these references. So you can go to these references and insert, just look up the tables, look up from the literatures, and just put the assign the values for each LULC class. So now let's go to the Excel sheet and put the values. So for 1, what we can do is choose 1 and put 0 and just double click, so that all the grid code 1 has the value 0. So again, now let's go to the 2, where 2 stands for 2 is our trees, so its value is 0.025. So let's put 0.025 and double click. Okay, so let's go to grid code 3, which gives its grass and gives 0.02. You can double click. So in this way I have added the C value for all the grid codes. So what we can do is we can now Control Shift down arrow, Control C, and go to our Arc Pro, and we can clear and paste. So it will add the values for all the grid codes. There you go. Okay, the next one is you save this editing. You can close this now. So again, now let's convert this polygon to raster, and the input features would be this one, and here the value field would be C. So let others be default, and if you run it, so now we have pixel. So now we have the C values for each pixel for different land use class. We can change this filter, symbology, and let it be be unique values. Yes, and yep, there you go. So this is how we will be assigning the C values for all the land use classes. So before using the USLE equation, we need to first project them and resample them to the resolution of the digital elevation model. So let's first resample and reproject them. We can go to the geoprocessing and we can click on resample. Okay, so first let's do with the C. Resample 1, the output size would be 30 by 30, and the environment, let's change the coordinate system. The Vietnam lies around UTM zone 48 north, WGS 1984 UTM zone 48 north, so I'm gonna click that one and click on OK. Let me recheck. This should be 30 again. 30 environment, and click on the run. So this gives us the resampled 30 meter the C factor. If you check on the properties, then it would be, yeah, it's 30 by 30. So let's do similarly for all other rasters. So I have resampled all the components of USLE. So now we will be using the raster calculator to estimate the average annual loss. So for that, we need to go to the geoprocessing, click on the raster calculator. Our formula for calculating the soil loss is this one, which is the product of R, K, LS, C and P. In our case, the P is given the value of 1, whereas we have individual layers for the rest of the components. So let's go to our Arc Pro, and in raster calculator, R multiplied by the K multiplied by LS multiplied by C. So let's give it a nice name, which is annual soil loss. So if we run it, so this is the final product. This is the final average annual soil loss in tons per hectare per year. So yeah, so the value ranges from 0 to 31,000, which is quite a big overestimation, but sometimes the pixel value could be outliers as well. So let's change its symbology and classify according to the classification threshold of the Vietnamese government. So as we can see here, this is the classification threshold given by Ministry of Science and Technology Vietnam in 2009. So this threshold might vary with the countries. So 0 to 1 is very low soil erosion, 1 to 5 is low erosion, and so on. So let's classify according to it. Symbology, click on the classify, and let's give, so 0 to 1, 1 to 5, 5 to 10, 10 to 50, 10 to 50, yeah, this is 50 to 100. So we can also like very low erosion, low, okay. Very low erosion, low erosion, high, is it high? Let me check. Medium, sorry. Medium, high and very high. I think you can also change the colors. Yep, so in this way we can find out the soil erosion map. We can also tally this map with the land use map. So in this way we can estimate the soil erosion and prepare a soil erosion map. So yeah, there are different pros and cons of using the global data set. The first advantage is that it can be the global data set are available for all over the world, but however it sometimes overestimate or underestimate because it does not use the local topographies and local informations. So I have some recommendations where we can use to improve our results. If the local data is available, then use those local data, because inclusion of the local information, the local the topography plays vital role in improving our results. There are empirical equations available for estimating the rainfall erosivity. In our case, the rainfall erosivity I think gave off a bit overestimation of the soil erosion. So the empirical equations are available for different regions, so we can check into literatures for that. Finally, the ground truth data needs to be collected and validated with the results so that we can improve our results. And these are some supporting links. I think I will be uploading this PowerPoint along with the video. So please check on this PowerPoint as well. So I hope you liked the video, and if you have further questions, please let me know. I would be happy to help you guys. Till then, bye bye. Thank you.